Hello everyone and welcome back to Cisco Free Training Online, and in today's particular training course we are going to talk about BGP. And before proceeding ahead with the BGP, let me give you a brief introduction about myself. My name is Faisal Ghulam. I'm a double CCIE and AWS certified professional, also a VMware certified professional. I've been working as an ISP and as a network consultant for almost 10 years. Now, what are we going to be discussing in BGP? This is not just an unusual training course that you can find it online. This is a training course where we are going to be discussing all the topics via a lab. So these are the questions that we will be discussing in the lab. Some of the questions, we have total 8 topics, total 8 tasks that we are going to be discussing in this BGP lab. And the lab has already been designed, the basic connectivity has already been set up. We can see that we have total 7 routers, and these are the different AS numbers: AS1123, AS4646, AS555, and AS777. In the first area, in the first AS, we are going to be basically also going to be configure OSPF. So as long as we go through different topics, we are going to be discussing about in detail about the topics of the BGP. So before proceeding, let's get to the different questionnaires. First of all, configuring OSPF area 0 in AS1123 for BGP network layer reachability information. So let me talk about BGP now. BGP is the protocol of the internet. We need BGP for communicating with different AS over the internet. That's the main reason we need BGP. So we have two different categories of protocol. There is internal protocols, and then we have external protocols. The internal protocol is the one which we configure in our own network, in our own AS, while BGP is required to communicate with different AS. So our internet, it's a big cloud. There are too many providers and transit providers that are connected, and they are connected to via BGP. Why we use BGP and not OSPF? Because we don't want to expose our internal network information to the rest of the AS, because that's our private information. So let's get started first with task number 1, configuring OSPF area 0 in AS1123 for BGP network layer reachability information. So this is our secure CRT terminal, and we will be going to our lab. So this is our lab. So without any further delay, let's start configuring the OSPF in area with AS number 1123. So it's going to be very easy. So we're starting with router 1. So VIOS 1 means it's router number 1, while VIOS 2 is router number 2. So after completing this course, you'll be having a good knowledge about BGP configuration, what are the core concepts of BGP and OSPF. So let's get started. The basic network reachability information is already there. So the first step is you have to configure the router OSPF 1, and we want to configure in the first link 10.1.12.0 0.0.255 area 0. So this is how you configure on router 1. We are also going to be configuring on the other router, network 10.1.13.0 0.0.0.255 area 0. Again, this is the wildcard bits, so we are matching the first 3 subnets, and this is how you basically do it in the first way. Let's get down to router number 2, and let's do the configuration router number 2. So router OSPF 1 and network 10.1.12.0 0.0.0.255 area 0, and also to configure on the link between router 2 and router number 3 10.23.0 0.0.0.255 area 0. That's it. And let's get down to router number 3, configure terminal, router OSPF 1, network 10.1.13.0 0.255 area 0. Sorry, it's not this one. 0.0.0.255 area 0, and also the other link between router 2 and router 3. The basic command for OSPF 10.1.23.0 0.0.0.255 area 0. There are also some loopback configured. One more important thing, we need to define the router IDs under the OSPF process. That's very important. Again, we need to have a simplicity while we are basically working on this. So router ID, as I mentioned there, 10.10.10.10. Yes, we will be clearing the IP OSPF process. Oh, sorry, yes. and we also need to define the OSPF on the loopback 0. So if you go to router OSPF 1 network 1.1.1.1 0.0.0.0, it's in area 0. Let's go to router number 2, configure terminal, router OSPF 1. Router ID is 20.20.20.20. Do clear IP OSPF process in order to take that change to take place. Yes, we want that. Interface router OSPF 1, and we are also going to define network 2.2.2.2 0.0.0.0 area 0 exit, and let's go to router number 3, configure terminal, and router OSPF 1, and we're gonna be defining the router ID, which will be 30.30.30.30. Do clear IP OSPF process. Yes, we want to clear the process, and also if we go to, we also want to define the OSPF on the loopback address. That address will be used for the BGP connectivity. We're gonna talk more details about that. Area 0. Okay, and we have now in the first step, what we have done, we had simply went to each routers. We have defined the interfaces which will be a part of the OSPF area 0 to do two things. First, to establish the neighbor relationship, and then to advertise those specific interfaces on which the IP address is configured to the OSPF process. We also defined the loopback on different routers to have the network layer reachability information via loopback when we are configuring the BGP. We are going to talk more detail about that, but in this particular question number 1, defining the OSPF peerings, the neighbors, and advertising the prefixes. That's it. If everything is done well, so we're going to be looking at show IP OSPF neighbor. If you click give this command, then we'll be having two neighbors, neighbor 2 and neighbor 3. Yes, you can see that we have two neighbors, and neighbor number 30 and 20. So 30 is router 3 and 20 is router 2. Show IP OSPF neighbor. Yes, we have full connectivity on here, 10 and 30. And show IP OSPF neighbor, and again we have like complete information. So if we have that particular thing that the neighbor relationship has established, let's try to reach loopback of router 1. Yes, let's try to reach the loopback of router 2. So it means that the connectivity is working. Similarly, we can double check on router 1. We can check for router 3, and also on router 1 if we ping 2.2.2.2 excuse me ping 3.3.3.3, we can see the communication is working between the routers. You want to see the OSPF route table. This is the OSPF table. You can see where we have this subnets 2.2.2.2, and we have this one 3.3.3.3, and also we are able to learn the interface or the link between router 2 and router number 3. So the complete network layer reachability information is working, and let's get down to the, so we have, if we talk about right now, so we have completed the OSPF in this particular area, in this particular AS. So let's start with the question number 2. So if we go to the question number 2, so the question number 2 is that configuring BGP in the complete topology between the routers EBGP and IGP, and make sure that R1 and R2 and R3 BGP peers using the loopback address, and R2 R3 configured as route reflector clients while R1 is route reflector. So let's go to the topology. That's going to make more sense. Normally in BGP we have two concepts. There is a concept of IBGP, and then there is a concept of EBGP. IBG, again, I stands for internal and E stands for external. So IBGP is appearing between two neighbors that are part of the same AS number. For example, in AS 1123 we peer between router 1 and router 2, or router 1 or router 3. The peering will be IBGP because we are doing the peering between the neighbors who are the part of the same autonomous system. And if we are doing the peering between different AS, for example between router 2 and router 4 or router 3 or router 6. So here this AS is 1123. They have their own administrative or autonomous system number. They have their own autonomous system number. So this peering will be considered as EBGP. So it's very important when we are basically defining that why we are configuring the EBGP peering. This is the first thing. The second thing, what we will be doing right now, we will be peering using the loopback address. The purpose to peer using the loopback address in the IBGP is, suppose router 3 has multiple paths to reach router 1, and if we are peering directly on a physical interface, and if that interface goes down, then we are going to lose our neighbor relationship with the router 1. So in order to retain that relationship, we will be using the loopback address. So we have one path that is down, while the other path that allows us to reach to that loopback address, then we will be able to still the neighbor relationship will be 1. So that holds true for all the routers in this topology. Again, BGP, the TCP protocol for the BGP is TCP 179, and it rides on top of TCP. And the reason we defined OSPF to have basic network layer reachability information. Now router 1 knows how to reach to router 3 loopback. Router 3 knows how to reach to router 2 loopback. If there was no OSPF, then we won't be having that reachability information. If we don't have the reachability information, then we won't be able to form a relationship using the loopback address. So it's very, very important. So let's get started and configure that. The other main concept we'll be talking here right now will be the route reflector. So what we'll be doing, that we'll be making router 1 as route reflector. We'll be making this router 1 as route reflector server, and router 2 will be a route reflector client, and also router 3 will be route reflector client. Now why we use the route reflector? So let me explain you a bit about the purpose of route reflector, because in this video we are explaining each concept as we go through the configuration steps. So normally what happens in our IBGP, or in particularly in BGP, so when suppose we have an AS, so we have this AS, then basically there are multiple routers in this AS. So suppose this is router 1, this is router 2, this is router 3, and this is router 4. Here we are explaining about the concept of route reflector and why we are using basically route reflector in the large autonomous system. So the purpose of route reflector is very simple. What we do is, this router, when it has any networks or any routes that it advertises, suppose it is having an IBGP relationship with it, it is having an IBGP relationship with it, and it is having an IBGP relationship. So they all are having IBGP relationship with each other. So when router number 2 advertise some prefixes to router number 1, router 1 is not going to advertise the prefixes to router number 3 and router number 4. The reason for that is that because in BGP, every single router has to have complete IBGP relationship. So router 2, those prefixes that are on router 2 will only be advertised to router 3 when router 2 is peering again with router 3, and router 2 is peering with router 4. So we have that complete full mesh of concept. So in order to get out of that particular concept, we need route reflector. We need those route reflector to have complete ease of feasibility, because route reflector works in control plane. The purpose is very simple. For example, we have a network. This is routers, and these are route reflectors client, and this is a route reflector, and they are peered like this, okay, and they're IBGP peers. So this router sends an update to this route reflector. So now route reflector will be able to send that particular update to the rest of the route reflector clients. So that particular concept where you have complete full mesh of IBGP peering to have the prefixes advertised throughout the complete topology is now does not matter, because now we have a route reflector that is working at the back end, and that is basically forwarding your updates from one router to another router without the need of complete IBGP peerings. That's the main reason we use this route reflector concept. So let's get started and do the configuration for the route reflector. Okay, so the configuration is very simple. we'll be defining route reflector in AS1123, and then we'll be completing the peerings with each other. So this is the step number 2. So without any further delay, let's get started. So configure terminal. We are on router 1, router BGP 1123, and no auto summary, no synchronization. The purpose of no auto summary is that normally once you advertise a prefix from one router to another, they will be automatically summarized. So we need those prefixes not to be summarized, so we have to disable that auto summary feature here. So very simple. First of all, neighbor, as we said, we're going to be peering using the loopback address neighbor 2.2.2.2.2. remote is the same, it's 1123. Neighbor 2.2.2.2. update source is loopback 1. Sorry, update source is, we have to define the update source 1.1.1.1. neighbor 2.2.2.2. update source. Okay, loopback 0. So I was like, the loopback was 0, it was not loopback 1. So we'll be doing that. This is the first. Why we are defining the loopback as like update source loopback 0? The purpose is very simple, because on router 1, when we are peering with router 2, we have to define that this is the IP address which we'll be using as a loopback. Okay, because we don't want that we are missing this point, and when router 2 tries to peer with router 1 and say like I want to create a neighbor relationship with neighbor 1.1.1.1, and in that case the router 1 is using its physical interface, so we need to define the source from which we are going to create the peering when we are defining the loopback address. So this is the first concept. So neighbor 2.2.2.2 update source is loopback 0, and this is the first, and then neighbor 2.2.2.2 route reflector client. That's it. So we want to see, these are the commands we have configured on router 1. So let's do the same on router 2. So configure terminal, router BGP 1123, no auto summary, no synchronization. By default synchronization is disabled. Let's create the neighbor relationship with the router 1 first, and its remote is same one, it's 1123. neighbor 1.1.1.1. update source is loopback 0. I don't know 1.1.1.1. loopback 1. Here we define update source 2.2.2.2 as loopback 1, and that's it. If we go to router 1, we need one more peering with the router 3 as well. So configure terminal, router BGP 1123, and neighbor 3.3.3.3 route remote is 1123. neighbor 3.3.3.3 update source is loopback 0. neighbor 3.3.3.3 route reflector client. Let's go to router number 3. We want to see what loopback we configure, because we are facing issues when we are just finding the, okay, very simple, router BGP 1123. You have to define from which router you want to peer. I want to peer with router 1, which is a part of the same as remote as 1123. I want to make sure that the update source I'm using is loopback 1, and no auto summary, no synchronization. That's it. Now let's see if the this is the IBGP peering we peered, and let's see if you're able to have a peering. Show IP BGP summary. It will take some time for router 3. It will take some time. We go to router 2, show IP BGP summary. So you can see that router 2, this is normally the BGP peering table. So we are peering with the neighbor number 1.1.1.1. The peer is up for 1 minute 54 seconds and there are 0 prefixes received. And let's go to router 3. The state is idle. Show run section router BGP to see the configuration here. Show run. BGP is a very slow protocol and sometimes it takes too much time to make the peerings up. But if there are any issues and the peering is not coming up, we can troubleshoot live. We might have missed something. That's okay, no problem. In the meanwhile, we can go to the rest of the topology and configure the EBGP relationship between the other routers. So configure terminal router BGP 1123 and neighbor 10.1.24.4 remote AS is 4646. No auto summary, no synchronization. Simple command to basically form the relationship here. On router 2, router 3 we do the same thing. Yes, you can see that the AS is 1123 but we are mentioning here 112. So what we can do is that we can go again, we can say router BGP 1123 no neighbor 1.1.1.1. again let's create the neighborship 1.1.1.1 remote AS 1123 neighbor 1.1.1.1 update sources loopback 1. That's it, and let's clear the process. It will be up now. So in the meanwhile, as you've seen that there are 2 commands when we are trying to create the peerings. The first is to basically have the neighbor command, neighbor, destination neighbor, and the remote AS, and then if you're using the update source as your loopback address, then you have to define, and that update source concept is only limited to your own internal AS when we are working with the real networks. So configure terminal router BGP 1123. Okay, let's see. If you want to see the magic to take place, we'll be going to 1, and I hope you're able to see both the neighbors, and excellent, you can see both the neighbors are up. So it was a small little typo error. We missed the remote AS, mistyped the remote AS. So IBGP OSPF configured, we're able to have the IBGP peering. So next step is to configure the EBGP peering. So what I will be doing quickly, I'll be going to all the routers, we'll be configuring the EBGP peering. When that is done, then we will be checking the peers are up or not, because this is the first step. You need to set the peering first before advertising the prefixes. Okay, now there comes a difference between OSPF and there comes a difference between the internal protocols and the external protocols. In internal protocols like OSPF, EIGRP, and RIP, the purpose of the network command is 2. First, you're just trying to establish the relationship on that interface, and the second is you're advertising that particular address or IP or subnet to the rest of the topology. In the BGP it works differently, because BGP is a huge routing protocol on the internet. There are like hundreds of thousands of routes on the internet. So the first step for you is to really establish the peering using the network command, neighbor command, and if you want to advertise the prefixes, then you use the network or you do the redistribution. That is the last step you'll be working on, but first this is the main concept that you have to keep it in your mind. Okay, the other thing, in the internal protocols you can only peer using the on direct interfaces. For example, R1 can be paired with R2, but here you have seen that we paired using the loopback addresses between R1 and R3, and loopback are not directly connected interfaces. They are like 1 to 2 hops away. So this works in the BGP. As long as you have the network layer reachability information, you're able to have that connectivity. You're able to peer using the loopback addresses, and This is the beauty of BGP. So quickly let's configure the EBGP configuration. So that's very important. And we have done on router 3, I think on router 2, the BGP BGP summary. Okay, so let's get started. On router 2 we have, so let's configure the EBGP on router 3. Very simple, router BGP 1123. Simple neighbor command, neighbor is 10.136.6. Remote AS, be careful while typing the remote AS. That's it. Very simple, straightforward, easy to use, enjoy. That's great, man. Okay, let's go to router 4. We have two EBGP peers in router 2. We are pairing with router 2 and we are pairing with router 5. So we have to be careful. Let's go to router BGP. We have to define in which AS we are. No sync, no auto summary. And neighbor 10.1.24.2, which is remote AS. We have to be careful. If we typo is there, then the peering is not going to come up. Then we are also pairing with router number 5, which is 10.1.45.5. Remote AS, you can see the remote AS is 555. That's it, very simple and sweet. Let's get down to router 5. Router 5, come on, come up. Configure terminal router BGP, it's very interesting with 555. And let's configure the neighbor 10.1.45.4. Remote AS, what is the remote AS, guys? It's 4646. Neighbor 10.1.57.7, pairing with router number 7. Remote AS 777. Exit. So we are done with it. Let's go to router number 6. Router 6, which is an AS 4646, pairing with router 3 and router 7. Configure terminal router BGP 4646. Okay, neighbor 10.1.36.3, remote AS 1123. Neighbor router number 7, neighbor is 10.1.67.7. Remote AS is 777. And we are left with the last router, beautiful router number 7, sweet router. Configure terminal router BGP 777. No auto, no synchronization. Synchronization is disabled by default. If you want to know the concept of synchronization, it's normally, I'm going to explain it later, but it's disabled by default. You don't need to get worried about this. So neighbor, let's pair first with router number 6, so 10.1.67.6. Remote AS 4646. Neighbor, let's pair with the last router 10.1.57.5. Remote AS is, come on, 555. Exit from the router, and that's it. We are done with the complete pairing, EBGP and IBGP. So before proceeding with the rest, once configuration is done, so we have configured OSPF area 0, very simple, very sweet. Then we have configured BGP in this step number 2, and we make sure that router 2 and router 3 are paired using the loopback. We also explain the concept of route reflector. Now we have the configuration is done. So the first step before proceeding ahead and playing with attributes or playing with the redistribution of the networks or prefixes, we have to make sure the BGP peering, whether it's internal or external, it's working. Because if there is breaking between the routers, if the peering is not up, then definitely you'll be facing issues. So we have to make sure first the peering is up. Okay, so we need to be careful, please guys, we need to be careful. This networking is it's like that. You need to be careful. You don't want yourself wasting up your time troubleshooting, and then later you come back and you see, hey guys, the peering is down. So let's get working with that. So first, starting with router 2. Okay, what's happening? A bit very slow. Okay, now let's get started. Very simple command, show IP BGP summary. If it's correct, you can see we're peering with neighbor 2 and now router 3, so router 2 and router 3 on router 1. Okay, and we can see the peering is up. 0 means the state is up, but we are not receiving any prefix. If the state is idle, if the state is active, if the state is not 0, in that case, then definitely there is an issue and we have to troubleshoot. You don't need to check router 2 and router 3 the status, because if it's 0 means we are able to establish relationship. Let's get down router 2. So we'll be peering with router 1 and router 4 if everything is working. So router 1 will be our internal and router 4 will be our external peer. Show IPBGP summary. Beautiful, beautiful. So this is router 1 and this is the direct interface we are using on router 4. Let's get down to router 3. If everything is working perfectly fine, then we'll be peering with router 1 and router 6. So let's see it. Excellent. We're able to peer with both. Let's go down to router 4. We'll be peering with router 2 and router 5. So IBGP summary. Excellent. That's fantastic. Let's go to router 5. Will be 2 EBGP peers. Perfect. We are peering with that. Let's get down to router 6. IBGP summary. Exactly. We're peering with router. We're pairing with router 3 and we're pairing with router 7. And let's get down to router 7, our last sweet router, and it will be perfectly fine. So excellent. Now we have configured the peering. So this is the first step. This is the first step. We need to make sure the peerings are up. There are no problems in peering. If the peering is down, we have to troubleshoot at that particular instant in order to avoid any problem later on when we're doing the advertisement of the prefixes. At the end of the day, we are doing all these peerings, whether it's EBGP or IBGP. The sole purpose is to have the reachability to those prefixes. So it is very, very important. So let's get down. So we have successfully completed this step number 1. We have completed this step number 2. We have completed this step number 3. Now here we go. Redistribute the loopback routes in AS555 using network command, and redistribute AS777 loopback routes using the redistribute command. So let me note it down here. So in AS777 we will be using the redistribute command. Okay, here will be, for these prefixes we'll be using the redistribution, and here we'll be using the network command. So there are basically two different ways you can basically advertise the prefixes into the BGP, whether you can use the network command and you can also use the redistribute command. Okay, so we can use both. So let's get started with the network command on AS555. Very simple and very sweet. Okay, I am doing both because I want to show you guys that how you can do that. It's very important to have the idea like how you can do that particular things. If you go to router 5 and configure terminal, and if you go to router BGP 555 and let's redistribute the commands network 50.1.50.0, and we need to define the mask, which will be in this case network mask 255.255.255.0. hold on, mask 255.255.255.0. Let's advertise the second prefix 20.50.0. mask is 255.255.255.0. okay, so this is how you basically BGP historic advertise the prefixes using the network command. Okay, and let's go to router number 7. Mostly I use the network command whenever I want to redistribute the prefixes into the OSPF, but we can also use the redistribute command as well. So if you go to router number 7 and okay, what we can do is that we can define an access control list to have both of these prefixes. Okay, so if you go to configure terminal IP access list standard, name is like a 10, permit permit 20.50.2.0 wildcard bits. Let's permit the other one 20.60.2.0. This is we define the access control list. And now if we go to the router BGP 777 redistribute connected, hold on, we have to define the route map. Route map name is like BGP advertisement and match okay, match IP okay, hold on, let me find out the access control list. So we have to match that particular access control list, and then we have to basically proceed with the with that particular okay, so we have to basically match the IP address, and the IP address is normally the access list number. And what was the access list number that we have defined? It was access list number 10. Okay, that's it. So what we are doing is that we are advertising those connected prefixes into the, so what we have done first, we have defined the access control list, okay, on which we have defined those prefixes that we are going to advertise into the BGP, and then we have basically matched those prefixes via route map, and now we'll be advertising those into the BGP. So router BGP, let's go to the topology. So if we go here, router BGP 777 redistribute connected route map. So what was the name of the route map? The name of the route map was, okay, hold on, okay, it was BGP underscore advertisement. We have to make sure the naming is correct, and it's okay, that's it, done. I hope BGP star. So now if BGP is working and there are no issues into the BGP, we'll be able to see these prefixes into the BGP table. So previously the BGP table was empty, there was no routes. Okay, there are three tables in BGP. There is a peering table, there is like BGP table, and then there is routing table. Any route which is best and valid into the BGP, that will end up into the routing table. Okay, so let's see right now. Okay, so we'll be starting with router number 7. I'm going to say show IP BGP. Excellent, so we are able to see these two particular routes into the routing table. Okay, and we are able to see these routes into the routing table. Okay, we go to router number 6. So let's get down to the other video. Okay, so now we have redistributed the networks in AS555 using the network command, and also in AS777 we have used the redistribution command. Okay, and if we can go to the routers and we can check if are we able to learn those prefixes in our BGP table. And if we go first to router number 4, and let's see, like, are we able to learn those prefixes in the BGP table? Yes. Okay, yes, we are able to learn the prefixes in the BGP table, and we can see that for example on router 4 if you see that we are able to learn the prefixes, as we have only this one particular route like path, and we're able to learn those prefixes, and all this star and greater than sign means that this is a valid and a best route. So any route which is a valid and a best, that will end up into the routing table. So this is the BGP table, and we can see the similar view in the on router number 5, in router number 4 as well, and router number 5 or router number 3 as well. So if I go to show IP BGP, exactly, we're able to see basically the same basically output in the same table as well. They are basically ending up as the best and the valid route. Okay, and if you just go now and just click on router 3 and check the routing table, show IP route BGP, and we're able to learn those routes as B, which is like these are the BGP routes. This 20 is the administrative distance for these routes, and this is being learned from 10.1.36.6. and now if we go to router number 1 and check, are we able to learn those prefixes, show IP BGP. So if you see here that we are having two exit points, so one is to router number 2, which is 10 dot router number 2, the other one is towards router number 3, but the routes are not valid routes. For example, if you see here, the routes are valid, but they are not the best route. If the routes are not best, then they will not up into the routing table. Should we say show IP route BGP, the BGP table will be empty. For a route to be a part of the BGP routing table, it should be the global routing table, it should be valid and best. Now these routes are valid, okay, but they are not the best routes. So in this case, when we are having a valid route and not the best route, then we have a concept which is known as the next hop self. Okay, so you can see here in the BGP table, the next hop 10.1.24.4, 10.1.24.4. This is the WAN link between router 2 and router 4, and router 1 does not have any information about this particular route or this particular network. For example, if router 2 advertised the prefixes learned from router 4, it basically advertised router 1 without changing the next hop. Okay, so in this case we have two options, either to advertise this network into the BGP, or we can use the second option, which is the next hop self. So on router 2 and router 3 we can change that. If you go to router number 2 and say configure terminal, so router BGP, it's a very important concept used in the IBGP. So 1.1.1 router BGP 1123 and neighbor 1.1.1 next hop self. So any prefixes that I'm going to advertise or I'm going to learn from my peering EBGP, I'll advertise to my IBGP router using my next hop. So my next hop with 1.1.1.1 is 10.1.12.12.2. So that is the direct link, so that will be reachable to me. So this is the single command that we have to use. If you say clear IPBGP star, okay, and do the same command on router number 3, configure terminal router BGP 1123 neighbor 1.1.1.1 next hop self. The prefixes I'm going to be advertising to my IBGP peer will be using my next hop. Okay, so we can wait for a minute, and if we clear the BGP process, when that is done, then we'll be able to learn the prefixes on 1, and the prefixes will be a valid and the best route. So let's go back to iOS 1. So previously the route, there were no BGP routes because the routes that were advertised were not best, because the loopback, the next hop was unchanged. So we have changed the next hop as next hop ourselves. So if we go to router 1 now, first of all, let's see the show IP BGP summary. So currently the state or prefix received is 0, so the peering is up. So sometimes again BGP is a very slow protocol, it takes some time, and once the peering is properly established, then it's going to advertise the prefixes and be able to learn the prefixes. It's still 0.00, so sometimes it takes too much time and people get worried and tense, like we have configured each and every single thing crystal clear, what's the point, like we are not able to learn the prefixes. It's still 0. It will take some time. The configuration and everything is perfectly fine. Exactly. Now you can see that we're able to learn the state or prefixes. So previously when we have seen the table, the routes were valid, but they were not best because the next hop was not reachable. It was the EBGP peer next hop, okay, and their BGP table was empty. Now let's try once again show IP route BGP. Here we go. We are learning all the prefixes, show IP BGP, and here you go, man. So this is how you basically learn the routes or the prefixes in the BGP table, and you can see that we're able to learn the prefixes in the BGP table, and this is how you do it. Okay, now we are able to give the next hop as 2.2.2.2 and 3.3.3.3. This is how we basically are manipulating the path at the end of the day. Okay. Okay, so this is how you do it. It's a next hop self. It's a very important concept, and we really need to be aware about that particular concept. And now what we have done, if we talk about step by step, we have configured OSPF because of the network layer reachability information. Then we have configured IBGP and BGP peering. We have redistributed the networks into the BGP. Then we were facing issue in router 1 that we were having those prefixes in our table, the BGP, but they were not the best. So we have to basically give the command router 2 and router 3 next hop self to make it valid. Now everything is working perfectly fine. Now it comes the final and a very, very important topic. If we go again to our task list, so we have configured this and we are able to see the routes without manipulating. We're able to see the routes on the BGP table. Now we are left with the attributes. So when you talk about the metric in the BGP, and it's very important to really talk. So now we are going to talk about BGP attributes. So BGP attributes are nothing just like in OSPF. In order to reach best path, we need metric, and the metric in OSPF is cost, and metric in EIGRP there are a bundle of it. For example, there is bandwidth, there is delay, and there's so many factors. So similarly in BGP, when we receive updates from our neighboring routers, we have to select one best route in order to reach that particular destination. So if we talk in BGP, there are multiple, it's a complete big list. So I'm not going to talk about each and every single thing. I'm going to just talk about bit of the important attributes in the BGP. So in the BGP, we want a route to be a part of the BGP table and to end up into the routing table. The first thing we have to see is the next hop that we are learning the prefix should be valid. When you talk about the next hop should be valid, means that the next hop should be reachable. The second attribute is the weight. The third attribute is normally the local preference. The fourth attribute is normally the if any route which is advertised with the network command, and the fifth one is local. Fifth one is the AS path aggregate, and the sixth one is normally the med. So I'm going to talk about each and every single thing. The first, there's a complete list. If you go to cisco.com and see the BGP attributes, a complete list. So we are not going to talk a lot about the different. So normally in the first 6, the decision takes place. So the first one is that the next hop self should be valid, and it means that the next hop self should be valid means that any route that you learn should be valid. If the next hop is not valid, so definitely the criteria does not move on. The weight is normally local to a router. Okay, for example, you have an AS and you have multiple routers, and you want to basically prefer a route from a different neighbor, so you're going to be using weight. So it's a locally, it's just like, it's normally a Cisco proprietary, and it's just locally on that router. It's not going to be advertised to the rest of the neighbors. The local preference, the concept is similar to a weight, but it's basically advertised to the complete autonomous system number. Network, any route that you're learning from your own network, AS path, so any route that you learn, because if you have one network, for example, this is one AS, this is another AS, and this is another AS, and suppose you learn one route double one, any route 10.10.10.024. So when you learn that route from this one, so it will be having an AS number. So that AS path is going to be appended at the end of the day when you're going to receive the final path. Okay, MED is nothing, just the multi-exit discriminant, like a metric. So let's demonstrate this concept demonstrated in the live lab. In the live lab, so let's demonstrate that concept here in the live lab. So what we're going to be doing right now, for example, if I show you here in iOS 1, so we are learning a bunch of routes in BGP table. Some of the routes we're learning from router 2 and some of the routes we're learning from router 3. If you see this prefix 10.1.57.0, okay, we are learning this path from router 3 and as well as router 2, but this particular router 1 is preferring this path via router 2. Now we want to prefer this path via router 3. So it's very simple, it's very straightforward. So what you can do is that you can go to that router, configure terminal, router BGP 1123, router BGP 1123. Now I'm explaining you how you can configure a wait command, and it will be locally to that router. So you're gonna say neighbor 3.3.3.3 wait is 100. So now what you're gonna prefer, you're gonna prefer all the routes from neighbor 3 because you have locally modified the wait to 100. Okay, and this particular command is not going to propagate to the rest of the network. So this is how you basically manipulate the wait. And if you want to see how we can basically manipulate the local preference, it's also very simple. And if you go to router 2 and you say enable configure terminal, router BGP 1123, and we're going to say that suppose what we can do right now, we can define a route map. In the route map, we are going to define that what local preference we want to set for those particular prefixes. So for example, let's take these 4 prefixes here. So these are the 4 loop 3 and loop 4 on this and that. So all these routes we are learning into our table. So what we're going to be doing is that we're going to be setting the local preference for these prefixes as we're going to be setting the local preference for these prefixes as on router 2 as okay, let me take the pen here. So we're going to be the local preference for these will be configured as 10, while this will be configured as 200. The default local preference is normally 100. So it's very simple. So if you go to the router 2, and if what we are doing right now, we are setting the local preference. Okay, setting the local preference 10 means like we are not going to prefer this direct path from router 2 to router 5, even though they are directly connected, but local preference has precedence over the autonomous system number. Okay, so if we go here at router 2, and what we're going to be doing is that we're going to be defining the IP, not a prefix list. What we can do is that we're going to say IP access list standard 100 10 permit 50.1.50.0/24. Hold on. Wildcard bits is again 0.0.0.255. We are defining 2 standard access list 50.2.50.0 0.0.0.255. Okay, and then we're going to be defining second access list standard for 20.50.2.0. hold on. Access list standard, this access list is 20 permit 20.50.2.0.0.0.255 permit So what we have done right now, we have defined two access control list. So we say show access list. So we have defined two access list 10 and access list 20. Okay, and when we say, now we're going to be calling them in the route map. So route map, so what we said, access list 10, the local preference will be set to 10. For this, the local preference it will be 200. So for access list 10, the IP address, the local preference will be set to 10. For this 20, the local preference will be set to 200 to manipulate the path. So we're going to say route map BGP advertisement. Okay, we're going to say match IP address. We have defined access list 10, set local preference to 10, then match IP address 20, set local preference to 200. Okay, so we have defined. Now what we're going to be doing, we're going to be now we have defined the access list on which we have an IP address, then we have match those particular access list and set the local preference. Now we have to define that route map on an interface. So we will be defining here on router 2. So we're going to say router BGP 1123 neighbor 10.1.24.4 route map. So route map, name of the route map is this BGP advertisement. Okay, and where we want to set that particular route map, we want to set in, means any prefixes that we are learning from router 4, and these are the top four prefixes, we want to prefer that particular route map to be applied inbound. We are changing the local preference to in. So we are going to clear the IPBGP process, and then you're going to see the magic is going to take place. The local preference is going to update automatically, and the router is going to change the path. So the previous path they were using, now they're going to be using different path to reach those specific destinations. So if we're going to do right now, we have to wait for some time, and then we will be able to basically see the change to take place. Previously it was okay. So previously this was the basically the BGP table. Some routes they were preferring to router 4, some of them they were preferring to router number 3. Okay, but now the change is going to take place, and for example, if I give you one example, so 20.50.2.0 20.50.2.0, this network was preferred via router 3, and just hold on, I hope the change has taken place. Let's see the BGP table now and see the change in the local preference. You can see the local preference has been changed. So this is how you basically set up this particular topology, and you can see that we have did this particular lab. And thank you so much for viewing this particular video. If you like this video on BGP, like my channel, subscribe my channel, and definitely if you have any questions you can ask in the question window. Thank you so much and have a wonderful day. Goodbye.